Hi everyone, welcome back to Chem Help ASAP. This video is all about the scientific method. Let's get started.
Let's talk about the scientific method. To illustrate it, I am going to use the famous Galileo and one of his many experiments on how objects fall. The very first thing he did was he made an observation. He saw that when you dropped objects, they fell to the ground. Easy enough, right? His observation led to a question: how fast do objects fall? His background research told him that Aristotle had said that heavier objects will fall faster. At the time, Aristotle's theory was the prevailing theory. However, Galileo made a different hypothesis. He proposed that if you had two objects of the same size and shape, but their masses were different, they should still hit the ground at the same time. What he was really theorizing was that it was air resistance that made, say, a feather fall slower than a solid ball. Now to his experimentation. This is the very famous story of him going up to the top of the Leaning Tower of Pisa and dropping two different balls. They were both the same size and obviously the same shape, however, their masses were different. And what he found was they hit the ground at the same time. This experiment was not done once, but done many times, and his analysis of his data led him to a conclusion. And that was that gravity will act upon all objects in the same way, that it is the air around the objects that can change the rate which they fall. His law or theory suggested that in a vacuum, if you drop a feather and a ball, they ought to hit the ground at the same time. Galileo was obviously not the only scientist to continue work on gravity. Many scientists took his conclusion and went back to his original hypothesis, or they went back and asked a different question. All of this leads to a more complete law or theory about gravity. 400 years after Galileo, Commander Scott of the Apollo 15 mission was on the moon. He dropped a feather and a hammer simultaneously, where there is obviously very little atmosphere, and both objects hit the ground at the same time. The scientific method continually cycles through itself to improve our understanding, and this is true in many different fields. In geology, the prevailing theory in the mid-1800s was that the continents were fixed. However, by the early 1900s, with experimentation and different conclusions, the theory of continental drift came into favor. But of course, geologists continued to ask questions, do experiments, and come to different conclusions. And by the mid-1900s, the plate tectonic theory was widely accepted. Even though this flowchart shows that we end at a law or a theory, that law is not necessarily absolute. We continue to ask questions, make new hypotheses, do more experimentation, and sometimes come to different and better conclusions.
I hope this video encourages you to try out your own scientific experiments. Thanks so much for watching.